Hello, welcome back to Blender Sushi Live Loading. In this episode, we're gonna revisit an older video, which is this SV multi-grease pencil tangency animations. Remember, we did the chain, and then we also vectorized the chain, but you might notice that the chain tool doesn't actually animate it. So I go back and then get this one, actually the SV multi-grease pencil with animations. And I'm gonna grab this and then gonna quickly turn it into vectorized kind of version like this one. You can see like all of the grease pencil strokes has all these different objects, and they are also animated, and it is also working for multiple grease pencil. So a lot of things going on here, but we can simply do this just by simplifying things like so I'm gonna grab this original one, grab it from GitHub, just right click and copy the link, and I'm gonna close Safari because it's pretty heavy for my computer, and I will reload a new fresh Blender scene, and this is Sverchok Add-On. Create a new one, import, just grab the keys. You should get the node tree ready for you. So this is what we have last time. I'm gonna simplify these nodes, like really I'm gonna get rid all of this at the end and kind of joining in the animated points. Okay, so anyway, I close Safari, and here's giving me error because it doesn't, because I haven't provided the grease pencil stroke yet. So I'm gonna delete everything, go to the top view for simplicity, and then gonna write BS for Blender Sushi. And this is a grease pencil strokes, and then of course we want to use it in Blender. Using Sverchok, you just use object ID selector, switch to grease pencil, and just grab the particular layer. I'm gonna pick a frame and plug this into this point, and then update it, and this should actually work. It's complaining about something. Matrix has index out of range, or actually because of this thing. Oh, I know. Oh yeah, that's actually the limitation of this setup. You need to have the right number of objects and then etc. So yeah, this is not the best setup. So I'm just gonna get rid of this. I'm gonna simplify the thing at the back here. I'll show you what I mean. So we have this at the moment. Okay, I'm gonna save this real quick. This is SV animated stroke vectorized. Okay, this is grease pencil coming in, and it is there's some kind of magic happening here with the animated points. You already know how this works. And at the back here, I also have this list input. This is actually very, very important. So depending on how many strokes you have, you need to specify the interpolation for each one of them, or otherwise you can use list length, and then, but I'm not gonna do that for now. We're just gonna worry about these points. So instead of having like many nodes at the back, we can simply actually just join it. We're gonna join all these points into a single data stream. Same thing with the tangent here. I'm gonna join them, join level list 2. And what's gonna happen is we simplify the whole data. So because we don't care about the point, we only care about the point position and point rotations. We don't need to keep all those data separate. We can just join them and then use them to instance our objects. So it's almost like particles instancing in a way. Kind of, before we have like multiple particle system. Now we just combine them into a single one. And if we use matrix into the locations and the angle there, we should generally, I think we should get something here that's it seems to be working. And the next thing we need to do is just to provide a bunch of polygon information. I can use the box and also the icosphere, the easiest, These two will generate, of course, box and icosphere, and Sverchok will take care of it. Once you provide the matrix, we simplify the whole system, like the whole animations, whatever. We don't care anymore. We just care about the transformations in the end. And I have box and icosphere. We know that we have 35 points kind of animating. So we just use please join once again. So this is slightly tricky because we have the vertices data and polygon data. We always need to care of these two, and we kind of need to combine them. And then we use list item to kind of separate them again. You will get a hang of it after a while. It should be level 1. I think this is correct. I might do this wrongly. Okay, this needs to be joined level 1, and this is actually level 1 as well. And now if we use a number like integer here, we can pick either to have the box or the icosphere. I'll reduce the subdivision of icosphere. You can see there. Okay, so it seems to be working. So this number is responsible for whatever objects being instanced to the points. And we can still control the sampling of the grease pencil. So now, yeah, it seems to be working. So all I need to do is to randomize this guy. So I'm gonna use random number generator, set to integer between 0 and 1 because we only have 2 objects. So it's should be like number like 0, 1, 1, like list of numbers. And the numbers count should be the same as this matrix count. So I will use list length to find out the total number of the objects that we need. So this level 0. So this guy just goes into the size. Plug this into the item, and we are pretty much done. So now, see, it's just worked. It's pretty incredible actually. And we can still control the size of the box, and we control the size of the icosphere, and we can randomize the seeding. This is just like particles. We have this is like a group objects coming into Sverchok, and then Sverchok will decide which one do you want to use for which points, and then this random number responsible for which item to be instanced into which point. Okay, so yeah, actually that's pretty much it. Actually, super simple. So the thing, there's one more thing that we need to take care of is this guy right here, list input. We can use just a number actually. Let's say if we say like a 10, this is mean 10 samples for each grease pencil. It's not like probably not very ideal because it's gonna create 10 sampling for each strokes. If we specify the strokes, I need to refresh like this. Okay, see, each strokes have 10 points, which is not the most ideal, but this will always work regardless. If we are using the list input, this is a little bit better because we can control the number of sampling per strokes. But this one is even simplify the whole thing further. But anyway, this is the whole idea. You can instance all kind of different objects into the points. We didn't use monad here. We simplify the whole thing basically. The chain one, you can actually modify so that it works this way. With the chain, you might have complexity with the rotation of the chain, but in this case, if you want to instance different type of objects and you want to use multiple strokes, this is how you do it. I'll show you once more with this. So we have two objects, right? This is list item and then list join. This is the thing with Sverchok. You have to take care of the vertices and the polygons separately, but that's actually can be advantageous as well. So anyway, this is if we have another object, for example, let's pick a ring. Let's use a torus. So torus is another generator, of course. Vertices and polygon goes in there. So we have another object now. Okay, and we need to increase the random number generator. And right away you can see it's updated. If I reduce the number, the details of the torus, you can see it's already working. I'll make this triangle. Okay, that's much better. You see, it just worked right away. It's just this list join and list item thing seems kind of complex, but if you maybe like frame it, it's can be simpler. Select this, frame it. This guy really just, so we have 3 objects goes in there, and then we tell Sverchok, okay, for these 3 objects, just randomly pick them by their index. This integer low and high number responsible for how many objects we are piping in, but the rest of them is really basically pretty simple. We've done this in the past actually. This is just like a couple of concepts put together, and we can end up with something cool like this. And yeah, let's write something silly. Snail. So it doesn't update right away, but we know we have the grease pencil, we have this data, so we just goes into the grease pencil here, and I need to refresh it, get this one, update, there you go. It's pretty simple, it's pretty powerful. Yeah, you can see the sampling is kind of screw up here. There's actually a way to fix that, but I'm not gonna tell you. Maybe you probably already know how to do it. You just use the length, find out the length of each grease pencil, and then based on the length, just use that number. Okay, that's pretty much it for this live noding. Hopefully this is useful. Again, this is just a combination of previous concepts that we have learned, put together, and then you have something that's simpler, more useful, depending on your needs. If you have any comments, suggestion, let me know in the comment section below. Thanks again for tuning in, and I'll see you in the next video. Thank you.